Fishing is mostly waiting. You cast the line, stare at the water, and you trust that eventually something will bite. And weirdly, making this game has felt exactly the same. Long stretches of invisible work with the hope that at the end, something fun will finally surface. Hello, and welcome back to Idle Fisher. I'm sorry it's been so long. I promise I've been working on it pretty consistently since I last posted about it. Other than like a 3-month break, then I stopped on working on these projects. Okay, I guess I stopped for a little bit, but I'm working on it now. That's all that matters, right? Right? Anyways, one of the reasons that I haven't posted a video in so long was due to the fact that most of the changes that I made were behind the scenes, which aren't really fun to watch. I got the loading screen to work. But I finally made a bunch of major changes to the gameplay and the back end that I thought would be interesting enough to finally make a video about. So don't worry, there'll be both fun non-programming changes and fun programming changes, depending on what you like. But I'm not going to go into any of the specific code. And there's another reason I wanted to make this video now. I'm getting close to something I've been wanting to do for a long time. A public demo. If everything goes to plan, I should have a playable demo out sometime in the next month or two. So you can finally try Idle Fisher for yourself, tell me what's fun, what's broken, and what absolutely needs to change. And if any of you want to be around when that happens, subscribing and wishlisting the game on Steam would really help out way more than you think. Oh, and I didn't even realize this at the time, but my ray tracing video was one day after my channel's first birthday. Happy birthday to me, I guess. Woo! But no time to celebrate. Aww. You got changes to go over. Before getting into the mechanics, there's one big visual change that sets the stage for everything else. The map. This is something I'd been putting off for a long time. The old environment worked, but it wasn't very visually stimulating. This is all it was. A box with a chimney, a box with a garage door, and I got creative with this one, a box attached to another box. But it definitely felt like a placeholder that accidentally became permanent. So I finally went back and rebuilt it with the goal of making the world feel like an actual fishing spot instead of a children's drawing. I got some help with the fisherman's house in the mechanics workshop, but then my artist gave up and I was left with this. So I had to do the rest myself. Starting in the center of the map, we now have the fisherman's house, which is where you'll sell your fish for money. The old dumpster was always meant to be temporary, but like everything else, it lived way longer than it should have. If we head down and to the left, there are 2 paths. Spoiler, they both lead to the same place. This is the dock where all the auto fishers live. I widened it a bit because before it got way too cramped once you had the fish transporters and a bunch of the machines running at the same time. Parked right next to it is the submarine, which is where the merchant will be. I'm still working on redesigning the NPCs, but I wanted him to have more of a sciencey feel, which would better explain why he has the ability to give the player all these upgrades. On the other side of the map, I added a stone wall separating the ocean from the land, with these big rocks along the edge. It added a lot more depth to the scene compared to the old, completely flat shoreline. Over here is the new mechanics building. He sadly lost his inspirational poster in the move. Oh, it's so bad. But I think he's pretty happy about upgrading from a shed to an actual house. And finally, over in this corner, there's a cliff, a river, a waterfall, and a broken bridge. This felt like a much more natural way of blocking the player's path than just slapping down a random fence and calling it a day. Although, to be fair, maybe in this universe, there's only like 5 people that exist. Who knows? The layout is still roughly the same, but now the world actually feels grounded, like somewhere you can actually imagine standing with a rod in your hands. Pause. And yes, you can fish from pretty much wherever you want. The docks, the submarine, over the wall, the river, and even the waterfall itself. Now with the world finally feeling like a place, it was time to fix the core feature of the game, the fishing itself. And for a while, it honestly just wasn't very fun. Originally, every time you cast your line, you had to wait a random amount of time, anywhere from 1 to 5 seconds, before a fish would even start pulling. There were upgrades to reduce that, but the base loop was still cast, wait, click, repeat. But to me, it didn't feel like an idle game. When I think of an idle game, I think of someone spamming their mouse button as fast as possible without stopping to breathe. And that's exactly what my game was missing. So I reworked the fishing around one simple idea. Remove the forced waiting and let the player decide the pace. The cast is now instant. The combo bar stays, but it's much more readable and reactive, and the fish continually moves back and forth instead of snapping back to the start every click. This alone already makes the system feel more active. But I also separated the green and the yellow zones so that they no longer overlap. Now you're constantly choosing between a smaller, higher risk green zone that grows your combo and a safer yellow zone that just maintains it. As your combo increases, the fish moves faster and the zones shrink, so the difficulty naturally ramps up instead of just being a flat timing check. And as you've probably already noticed, I've changed the combo widget, making it a lot bigger and adding a shake effect the greater your combo is. I thought this added a nice sense of urgency. I also made the combo system a lot less punishing. Before, if you pulled your rod out of the water for even a moment, your combo was gone. This felt awful, especially if you misclicked or got interrupted. Now there's a short grace period where you can put your bobber back in the water and continue the chain. At the same time, because the fish no longer resets at the start of each fishing cycle, I added a gradual combo decay if you miss a cycle. And if you miss and click the blue zone, it drastically drops instead of resetting it. So it still feels challenging, but now it feels way more fair. Alongside that, I completely changed how the fishing rod works. Before, they were just a linear list. You buy the next rod, it gets better, you repeat. It worked, but it didn't really give the players a meaningful choice. Now there's a single rod with 3 upgrade paths: power, speed, and catch chance. Power determines what tier of the fish you can catch, speed affects how fast the fish moves along the bar, and catch chance is a percent-based system inspired by games like Hypixel, where for every 100 points guarantees an extra fish, and any remaining points is used as a chance for another drop. I also wanted the upgrades to be visible, not just a number in a menu, so each path maps to a physical part of the rod. Power maps to the rod itself, speed to the line, and the catch chance is the hook and bobber. Don't worry, it's not just the color that's going to change. I'm still trying to figure out how to integrate this cleanly with the character's animation without having to redraw everything hundreds of times. But the foundation is there. Once the core loop felt better, the next big thing that stood out to me was performance. And this is where I have to admit that I absolutely have no idea what past me was thinking. I think your grandma who needs help getting to Google could have written better code than this. Let me show you what was so bad about it. Pretty much, for every object, every frame, I was essentially saying, hey GPU, draw this. Okay, now this one, oh, and this one too. Thousands of times per frame. It worked, but it was like commanding an army to send a single command via messenger pigeon for every individual sword swing. You have a whole army, but by the time the pigeon comes back to send another message, you're just using the same troop, and the rest of the army is wondering, are we really just supposed to stand here? Then while the one troop is fighting for his life, everyone else is just sitting down and having a tea party. Instead of issuing a separate draw call for every single object, I now queue all the draws up on the CPU, then send the GPU one set of instructions. This is what GPU instancing is, and the moment I switched to it, my FPS went from around 300 to around 2000. A slight improvement, but don't worry, it gets worse. While implementing GPU instancing, I noticed that I was updating the information on the GPU very poorly. Before, every time I wanted to change something in a shader, I just asked the GPU where that variable even lives, wait for the answer, and then send the actual value. That's 2 round trips per variable, per frame, per object. Now I cache all the information once and reuse it, so setting the shader data becomes a single direct operation. And if the value hasn't changed, I don't even send it again. Less waiting, less overhead, more actual drawing. Once again, it gets even worse. I don't even know how I messed this up. Previously, when I would set the location of each object in my game, I would for some reason completely re-upload the object's data. For all you non-programmers out there, I'm pretty much sending in a new list of points to the GPU every time an object moves. Instead, I just send the data to the GPU once, then just use a simple location variable to move it around. So much simpler and a fraction of the data. Finally, one of the more specific optimizations was the fishing rod itself. Originally, the line was built out of a bunch of rectangles created and destroyed every frame on the CPU. It looked fine, but it was incredibly wasteful. Now the CPU just defines the start and the end points in a few parameters, and the GPU handles the rest procedurally. Visually, nothing dramatic changed, but internally went from hundreds of object allocations per frame to basically none. Once the core rendering and gameplay loop were in a better place, the next layer that really needed attention was the UI system. For a long time, it technically worked, but it was held together with a lot of assumptions that only stayed true as long as the window size never changed and the layout never got complicated. The moment I started adding real menus, blur effects, and changed the resolution, it became apparent that there were a few problems. One of the first structural changes I made was switching the coordinate system so that 0, 0 was at the bottom left instead of the center of the screen. Again, I don't know why old mate thought it would be a good idea to put it in the center of the screen. It makes everything so much more confusing. Having the origin in the bottom left is also what almost every other UI system uses. It might sound small, but it made the positioning and scaling much more intuitive. Along with that, I also added an anchor and pivot system. The anchoring would be bottom left by default, but if I decided to anchor something in the top right, then it would always be in the top right corner of the screen, no matter the resolution. In the pivot is where the object is relative to the size. 0, 0 would pivot to the bottom left corner, and 1, 1 would be the top right. On top of that, I rebuilt the parent-child system for widgets so that UI elements could actually behave like a hierarchy instead of a flat list that just happens to draw in a certain order. Now every panel, button, and text element lives in a tree, and when something moves, resizes, or changes parents, the change propagates correctly through all of its children using proper traversal instead of a bunch of special cases. While going through and changing all of my UI to work with this new system, I realized how boring the pause menu looked. It's kind of just some text with some buttons. It definitely gets the job done, but we could do a little bit more here. So I decided it would be a good idea to spend hours figuring out how to make a nice pixelated blur that would overlay the whole screen. To make this work, I had to render the entire scene into an off-screen texture called a frame buffer. Imagine this as like a Photoshop layer. Then run a blur shader on it, render it back to the main screen, and finally finish drawing the frame. That meant introducing a proper frame buffer system and making sure everything resized correctly when the window changed. At first, resizing the window would just completely break everything because the frame buffers themselves weren't resizing. Since we're on the topic of resizing the screen, I also changed other things like the opening circle animation, because before it was hard-coded to work with 1080p monitors, and now I pass it to the GPU to solve that problem for me. And this background component that I made, which is able to resize without distorting the edges or corners, so I can have different size objects inside without the need for hundreds of unique images. Input handling also got a full rewrite. Originally, hover detection was basically a counter that went up when the mouse was over something and down when it left, which sounds reasonable until anything unexpected happens, like the UI disappearing or overlapping, which led to all kinds of weird edge cases where the button would stay hovered forever or clicks would go to the wrong element. Now, every clickable widget registers itself each frame, and because the UI is drawn back to front, the last element under the cursor in that draw order automatically becomes the active one. That means overlapping panels and pop-ups all behave correctly without any special logic. And the mouse system naturally respects visual depth. All of this UI work is also tied directly into making the game feel more like a real desktop application. There's now a full setting menu with monitor selection, resolution, frame rate caps, and VSync. And importantly, these settings don't instantly apply the moment you click them. You have to press save, because otherwise it could just get pretty annoying. Under the hood, this also meant separating current runtime settings from pending settings, and making sure everything can be cleanly reinitialized when a change is confirmed or reset. Loading I gotcha. I had you checking the video, didn't I? Loading was another huge focus, because previously the game would just freeze until everything was in memory, and on slower drives, that could take long enough for the operating system to think the program has crashed. The new system only loads what it needs to display for the title screen, then continues loading the rest of the game in the background while you're sitting in the menu. By the time you press play, most of the heavy work is already done. To make all this reliable, I had to rethink of how assets are stored and accessed. The game now uses a custom package format instead of loose files, which means all images, audios, shaders, and data live in a single compressed archive. This prevents easy tampering and simplifies distribution. But it also has a slight downside. It uncompresses the data, which is great because the loading speeds up drastically, but the file size slightly exploded. I had no idea how good compression was until I did this. Currently, I have a little over 1,000 images, and the total file size of all of them is only around 3 megabytes. But when uncompressing them, the file grows to, actually, take a guess. What do you think it would go up to? Maybe double, go to 6 megabytes, or even triple, or 10x? No. Uncompressed, the images take up 341 megabytes, which is more than 90 times the size. Luckily, this only really changed the file size of the game. I was able to get the memory usage to actually decrease. This is because I also changed how textures are stored. On load up, I load all of the textures to the GPU, then only keep a copy of the bytes on the CPU for what I need. For example, some of the objects only work if the mouse is over an opaque pixel. So on the CPU, I will only keep a copy of the alpha channel. This optimization brought the game from around 400 megabytes of memory to only 100. Saving also got a much needed upgrade. The original system was based on CSV files, which worked fine until the moment I needed to change the structure. Adding or removing a single file could break old saves entirely. Now everything is stored in a structured JSON, which means I can add new values, keep old ones, and even migrate data between versions without corrupting players' progress. Save files also move to the standard application data directory, which is a small change that makes a big difference in terms of professionalism and cross-version compatibility. By this point, I finally feel like Idlefisher has a real backbone. Before, it was a game that worked on my computer at my resolution with my settings, and if anything went slightly wrong, the whole thing kind of fell apart. Now, the UI scales properly, the input system behaves, the renderer is fast, loading happens in the background, saving is future-proof, and the game just holds together. It feels less like a bunch of things thrown together and more like an actual game engine supporting an actual game. And that's why I wanted to make this video now. Not because everything is flashy and finished, but because the foundation is finally solid enough that I could start focusing almost entirely on content, progression, balance, and making the game genuinely fun instead of fighting technical fires every week. This is the version of the project where things will hopefully start to accelerate. If everything goes according to plan, the next big milestone is a public demo sometime in the next month or two. You'll be able to play the first world, try the fishing, upgrades, pets, and progression. And most importantly, tell me what works, what doesn't, and what you want to see next. If you're interested in that, wishlisting the game on Steam really helps, and subscribing lets you know the moment the demo is ready. So yeah, thanks for sticking around, thanks for watching, and I'll see you in the demo.